All right, we are now going to tackle a brand new number system. This is new to you guys. You haven't seen this before. So if you guys remember back in the day when I told you about whole numbers, and then those are like 0, 1, 2, 3, 4, 5, and then we went to integers. Okay, integers are negative numbers and 0 all the way to infinity, negative infinity, positive infinity. Then we went to rational, and rational can be expressed as a fraction. So all integers and whole numbers are rational numbers, but also you can have things like, 3/4. That's a rational number. And then on the other side of it, rational was irrational. Things like the square root of 2, pi, square root of 5, those kind of numbers, they're irrational, and those two don't meet. And then we said that these numbers together, both of these sets together were called the real numbers. And you have been working with real numbers your entire math life. Okay, now today you are going to learn what's the opposite of real? Imaginary. Imaginary number system is over here, and it is not part of the real system. Okay, it is imaginary. And if you want to put the two together, this number system here is called complex. This is the complex number system. It consists of imaginary and real. And I don't think we get enough into it in this class because we're using the ALEKS curriculum, but typically in a book, you would learn how to write every single number in a complex form, meaning its imaginary piece and its real piece, which is kind of fun. But today, we are just going to be learning on basically what is an imaginary number and how to manipulate them. So I'm going to go ahead and rewind all of this because I need the space. Okay, so number systems, we are heading into imaginary numbers. And the reason why we had to do this is because remember when we were doing square roots before, and you can't take the square root of a negative number, and we would just say, you probably don't remember this, but the answer that you used to have to put for this is not real. And they didn't mean not real like it doesn't exist. What they meant is it's not part of the real number systems because it's imaginary. So the square root of negative 49, okay? We're going to go ahead and figure this out, but first you need to know the definition of imaginary numbers, okay? So here's the definition, and you need to have this down. Okay, here you go. The square root of negative 1 is I. That's it. Okay, or backwards, if the square root of negative 1 is I, then I squared is equal to negative 1. Get it? There's two numbers that exist. You can't think of any real numbers that you could multiply together that are the same that would get negative 1. That's why they are imaginary. So I times I equals negative 1. Okay? Once you drill this into your brain, and I really mean you need to take a moment and you need to accept it and you need to roll with it, everything is going to be super easy because then all we do is tackle negatives as i's. I mean, like the square root of negatives is I. So take a look. We can separate this as I times, not I. Oh my goodness. Oh my goodness. Okay, let's try this again. We can separate this as negative 1 times 49. Well, the square root of 49 is 7. And the square root of negative 1, by the way, I cross out the square root when I do it to make sure that I'm taking the square root and I don't leave it there. I. So the answer is 7i. And sometimes it can be plus or minus. It just depends on which book you're reading and when, okay? Because you could have, it could be both positive and negative, but let's just go with 7i for now, okay? All right, let's take a look at next one. It says take the negative of the square root of negative 48. So I'm going to pull out the negative 1 right away. And then I'm going to split 48. Now, I don't know if you guys remember this. This is very, very much in the geometry realm. I know we should have done a lot of it. I don't know if we were heading into this or if we actually covered it. But to simplify the square root of 48, you need to go back to your squares. You're trying to pull out the largest perfect square, or at least perfect squares. And if you don't remember what perfect squares are, they are, let me do them in a different color. Perfect squares, I'll do them down here. Perfect squares are like 1 squared, which is 1, 2 squared is 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 7 squared, 8 squared, 64, 9 squared, 81, 10 squared, 100. You get the idea, 121, 144, 13 is 169, 14 is 196, 15 is 225, and then I kind of lose it. Okay. I think 16 times 16 is 256 because that's like a computer number, isn't it? And then I forget 17, 18, and then I get 20 is 400. Okay, you kind of should be able to recognize these numbers because they're going to pop up a lot. Okay, so the idea is that you're looking for factors of 48 that might be a perfect square. So come to these perfect squares, okay? 4 goes into 48. So let's pull out a 4. 48, we're breaking it up. You guys are breaking 48 into pieces so we can take the square root pieces. So it's the square root of 4 times 12. 4 times 12, right, is 48. Oh, look, I can break up 12. 12 is equal to the square root of 4 times the square root of 3, is it not? Okay, and now guess what? I can actually solve this. I can find my square roots. Go green. Okay, the square root of square root of negative 1 is I. Square root of 4 is 2. The square root of 4 is 2. And then there is no square root of 3. So you leave it as it is. We're not going to use a calculator. So 2 times 2 is 4. Times I times negative 1 is negative 4I. Okay, but then we still have that square root of 3. So what order do we put this in? It depends on the book that you're reading. A lot of times it would actually come like this, but I'm pretty sure Alex likes it like this. And then you put the I here. Okay. In essence, it's all the same because it's just, these things multiplying by each other, but I think that's the way Alex likes it. We put the imaginary piece at the end. Actually, that's just typical. We typically put the imaginary piece at the end. Okay, I'm going to get rid of that. So let's take a look at negative of negative 24. So negative of negative 24. So we're going to take out the negative 1 and now do 24. Okay. I could do it like this, you guys, just to show you the pieces, the time, the breakdown. So 24 is 4 times 6. 4 is a perfect square, so we want to pull it out. Okay, the square root of negative 1, I. Square root of 4, 2. There is no square root of 6. And then the negative is here. So the answer is going to be, put the real part first, negative 2 square root of 6, I. Okay. And that's how you do those. Next. Okay. Now you're going to have to learn how to multiply them, divide them. Okay, multiply and divide them, add and subtract. Okay, so first we're going to learn how to multiply. Multiplying is easy because all you need to do is multiply the numbers underneath the radical. Okay, basically, if you think about it, look, real is going to interact with real, and the radicals are going to interact with the radicals. It's just the way it feels, kind of like I don't want to say like terms eventually, but it kind of feels like that. But multiplying, basically what we're going to do is we're going to multiply underneath the radical. I always say, like, if it's in the house, the radical be in the house, leave it in the house until you get the square root. So you operate underneath the radical. So this becomes 7 times negative 11, and that's negative 77. Okay? And then it says, leave no negative numbers under the radicals and no radicals in the denominators. Okay? So we haven't talked about that yet, but here we go. Can't leave the negative out. Okay? So we're going to take it out. It's going to be I, because the square root of negative 1 is I. Square root of 77. Alex may have you put it in as this, 77. Not sure. Okay. Next. Okay, there is a rule. Okay, you may not leave no radicals in the denominator. You may not leave them in the denominator. You have to, what we call denominator. Write this down. You need to rationalize the denominator. Rationalize the denominator. And how do you do that? Okay, that is kind of a trick. Okay, what we know is that, take a look. If we want to do something like square root of 3, or I don't want to say if we want to do something, and we're going to take advantage of this. The square root of 3 times the square root of 3 is equal to the square root of 9, or 3. Do you get it? You could just jump to here. Because look, the square root of a times the square root of a is equal to a. Because it's equal to the square root of a squared, which is simply a. Okay, we're going to take advantage of this rule right here, right now. Okay, what we're going to do is we're going to rationalize the denominator. And the way we do that is we decide to multiply this by the square root of 10. Why? Because we are going to make this rational, because the square root of 10 times the square root of 10 is the square root of 100, or 10. And then you can't just multiply the denominator. We also have to do it on the numerator. See, this is just a fancy form of 1. So we're going to get the square root of negative 70. Okay, then we're going to go ahead and try to see if there's any, are there anything? No, there's no perfect squares that go into 70 because 2 goes in there, 35 goes in there, 10 times 7, no. So all we can do is pull out that I. So we're going to pull out the I, or if you want, you can go through the steps of the square root of negative 1 times the square root of 70 over 10. And then that would be the square root of 70, I, because this is I, over 10. Again, it's just simplifying numerator, simplifying denominator. Let me go ahead and move this down a little bit, or up a little bit. Okay, so take a look at this one. Okay, there's a couple different ways to do this one, and I want to go over it because if you recognize it initially, it might save you time. Okay, as I told you, we could rationalize the denominator here. Okay, don't know what I did, but okay. We could rationalize the denominator by multiplying by the square root of negative 3. This is just 1, okay? And then you would get 81 times 3, 3 positive, it turns to a positive number. It's 3 and then 24, 243, okay? And then you would have it over 3. My bad. Hang on. Started writing the square root of 9, and I don't want to do that. Okay, negative 3 times negative 3 is 9. So you would get the square root of 9, which is 3. I don't know why I did that again. Okay, sorry. Let's do that. 3. Okay? Then you'd have to simplify this square root, which is kind of silly, you guys, because you wouldn't want to multiply it out, because literally you'd want to break it back up into 81 times 3 over 3, because the square root of 81 is 9. And then 9 divided by 3 is 3. So you get 3 root 3. That's kind of the long way to do it. There's a faster way to do it if you recognize that 81 is divisible by 3. You can use the division rule, which goes like this. 81, negative 81 over negative 3. You can rewrite it. Okay, this is the rule right here. This is interchangeable. If you have the square root of a over the square root of b, it can become the square root of a over b. Okay, so look, what I did was I eliminated the two radicals and I put them under the same radical because I can divide that. 81 divided by 3 is, 3 goes into 81. It goes in there, what? 2 times, and then there's 2 left over, 27. Okay, it goes in there 27, and now you just need to simplify the square root of 27. Are there any perfect squares that go into 27? And the answer is yes, it's 9. 9 times 3 is 27. So you take the square root of 9, which is 3, and your answer is 3 root 3. I think this is so much easier than this one, okay? But you have to recognize that these are divisible, okay? Square root of negative 6 times the square root of negative 6, you guys, is just going to be, this is tempting, okay? It looks like as if it would be negative 6. Don't be tempted to do that, because there is a negative there. It is going to be the square root of 36, which is 6. Let me show you. Even if you were to do this with i's, let's say you broke this up into negative 1 times square root of 6 times the square root of negative 1 times the square root of 6, right? This is this negative 6, and that's that negative 6. This is I, and this is I, right? Well, what's I times I? I squared times square root of 6. And I squared is equal to negative 1. So it's the negative square root of 6. Ooh, wait a minute. No, that's I root 6, I root 6. Oh, wait, it's 6i. Oh, my God. I'm losing my brain. It's 6i. It's negative 6. It is negative 6. Oh, my gosh. This is what you don't want to do. Hello. I actually needed to go through the I rule for that. You guys, let me actually clear that up. Okay, let me clear that up. Let me get this. Okay, I don't want this bad stuff there. All right, so I guess the point of that is that you could use that rule. Negative 6. Oh, let me clear this one up too. I put the square root of 6. Oh my God, I totally screwed this problem up. All right, guys. If I had editing power, I would totally edit that out and fix it, but I don't. So, hey. The way you want to do that, you could absolutely use the rule of square root of a times the square root of a equals a, and that would be negative 6. Okay, I actually wrote that earlier. Square root of a times square root of a is equal to a. All right, you could also break it up, and I'm going to do it correctly this time. Sorry, guys. Square root of negative 1, square root of negative 1 times the square root of negative 6. This is I. This is I, and 6 times 6 is the square root of 36, or 6, okay? So we're going to get I squared times 6. I squared, though, the definition of I squared, write this down if you need to, is negative 1. So this is actually negative 1 times 6, or negative 6. A couple different ways to go through that, all right? Even here, you could have done, and I wonder if some of you guys thought of this. No, I won't confuse you. I'll do another way. Okay, here we go. I'm sure Alex will have a way too. All right, now we're adding or subtracting. Remember, when you have a minus and you have parentheses, you need to distribute that minus sign, and that's what we're going to do. So we're going to go negative 4 plus 5i. We can take the parentheses off the first one. and then plus 5 minus I. Do not forget to distribute it to the second term. Okay, then now you add your reals, and then you combine your imaginaries. So my real numbers are negative 4 and 5, so it's going to be 1 plus 4i. And that is it. And this is a complex number. Remember I said complex number is real? This is the way we write complex numbers. We put the real piece first and then the imaginary. All right, I don't like this blue. This is ugly blue. I'm going to change out this blue. Okay, let's get this blue. All right, let's move this up. Okay, here's another one. You can try it. You can pause it. That wouldn't be bad. Distribute that negative. Take away the parentheses so you can actually operate. Do not try to add anything through the parentheses. It's not allowed. Okay, so I distributed the negative to both terms. To both. Negative times negative is positive. Negative times positive is a negative. All right, and now I'm going to add the real pieces. That's 4. And the imaginary pieces, minus 2i. Okay, and that's it. It feels a lot like adding variables, like terms. Okay, again, last one. If you need to practice one more time, if not, jump to the next one, okay? So negative 1 plus 6i plus 2 minus 2i. Real numbers 1 plus 4i. I think I'd put 3 here because this is a common one that people miss, and I don't really understand why. I think it's only if they haven't studied it or something. I'm not exactly sure. Go away. Okay, let me go back 100%, and then we are going to go pull this up. All right, now you need to learn how to multiply. So you are going to use FOIL again, okay? So we're going to go first outer, inner, last, and we're going to use, remember, I squared equals negative 1. That's what we're going to use here. Okay, so we got negative 1 plus 6i times negative 5 plus 4i. Okay, so we're going to go here. Negative 1 times negative 5 is positive 5. Negative 1 times 4i is negative 4i. You can have a negative I, it's fine. Okay, then you come here, negative 30i, and then you get plus 24 times I squared. Okay, so now you got to come here and simplify it. So when you simplify it, you got to look that I squared by definition, right here, I squared is equal to negative 1. So what this really means is 24 times negative 1. Okay, and then you come back and you're going to add real terms. So real, well, I'll rewrite it. I'm going to add these two together, the imaginary, minus 34i, and then we're going to go minus 24. See, because the I squared is going to make it a negative 1. And then we combine our reals, negative 19 plus 34i. All right, next. I do the little curvy I, you guys, because that's kind of the way they write it. That is definitely a little excessive on the curve, but it almost looks like a U. Just roll with me. Okay, there we go. Now it looks like an I. It has a dot. Okay, come on. Come on, Peter, you got this. Do this. Okay, here's the next term. Next one. All right. Let's go ahead. Let's pick purple. Okay, so negative 5 plus 6i times negative 1 plus 2i. Okay, distribute. You're going to get 5 minus 10i minus 6i plus 12i squared. I squared is negative 1. So that means 5 minus 16i minus 12. So simplifying it all the way down, and there you go. Okay, last one. If you need one more example, I did 3 just in case. Okay, let's go ahead and do this. you get 6 times 4 is 24. 6 times negative 2 is negative 12i. 4 times negative 1 is negative 4i. Negative I times negative 2i is plus 2i squared. Okay, and this, I'm going to go ahead and just write it out in the next step and not be so lazy. This becomes negative 16i, and this is 24. So we get 24 minus 16i minus 2, so it's 22 minus 16i. Okay, all right, next. All right, now comes the hardest part. These are the hardest problems of the entire little piece, topic of complex numbers. And the reason why is because you need to rationalize the denominator. Okay, you cannot have imaginary numbers in the denominator. Not allowed, you guys. So as you can see, we're very picky about our denominators. We can't have radicals in the denominator. We can't have imaginary numbers in the denominator. We can't have a 0 in the denominator. Okay, got to have it right. So this is the trick. 5 plus 2i over 3 minus I. Okay, this is imaginary. And we need to get rid of this 3 minus I, and we have a problem because if we multiply it by I, that won't work because you could see, you're like, oh, I'll multiply it by I. But then that means I would have 3i minus I squared, and this becomes negative 1, but that doesn't help because I still have an I. So we're going to use a trick, okay? And this is called multiplying by the conjugate. Again, we're rationalizing the denominator, okay? Rationalize the denominator by multiplying by the conjugate. Now, lovely word, conjugate, okay? What that is it's going to be the binomial that multiplies so that it will get rid of the imaginary number, and here it is, 3 plus I. That's what we're going to multiply this by. Do you see how it looks like almost like the difference of 2 squares? Okay, remember the difference of 2 squares? Remember that? All right, but you can't just multiply the denominator and not multiply the numerator. This is just a really fancy form of 1, okay, which means we have to put this in parentheses, and we're going to have to use FOIL. I'm going to work down because obviously I wrote over there. So we're going to FOIL the top. We're going to get 15 plus 5i plus 6i plus 2i squared. Okay, all over. And then difference of 2 squares, 9 minus I squared. I could do, FOIL, 9 plus 3i minus 3i, but that's going to cancel. So you get 9 minus I squared. Okay, keep going. We're going to combine, okay, what we can, 11i, and then I squared is going to become negative 1, so it's going to be minus 2, and this I squared is going to become negative 1, so it's going to be 9 minus negative 1, okay? So we get 9 plus 1, okay? And I'm going to have to go over here. So I'm going to add the real pieces. I get 13 plus 11i over 10, and that's my answer. Okay, all right, that might seem a little bit complicated, so let me shrink this down a little, and I'm going to go ahead and do the next problem over here, okay? So it says negative 6 minus 6i over 6 minus 4i. Okay, we need to rationalize this denominator. Okay, you know what? I'm going to leave it, but I'm so tempted to divide everything by 2. There's no reason everything needs to be multiplied by 2 right here. Excuse me. But I'm going to leave it. Excuse me. Dang it. I'm so sorry. Okay, so we're going to multiply to rationalize the denominator by 6 plus 4i. Okay, we multiply the denominator, we must multiply by the numerator as well. Okay, there we go. Now we're going to FOIL. We get negative 36 minus 24i minus 36i minus 24i squared. Okay, all over 36, okay, difference of 2 squares, minus, and you can FOIL it out if you don't remember the difference of 2 squares. Okay, I squared is -1, I squared is -1. It's going to change that to a positive and that to a positive. So here we go. Negative 36 minus, what is that? It's 10, add 160, 60i plus 24 all over 36 plus 16. And that's going to become 42. So it's going to end up being 36. Negative 36 plus 24 is negative 12. Yeah. Negative 12, 60i all over 42. And guess what? You're still not done because you need to divide it all by 2. Every single one of these numbers is divisible by 2. You can't do this if they're not all 3 divisible by 2. So we're going to go negative 6 plus 30i all over 21. And that is your final answer. Okay, let's go ahead and go back to the next page. Okay, I did 2 more problems. And the reason why I did so many problems is because this is super brand new, really uncomfortable in the beginning when you start. So I didn't want to like rush through it at all. So let's try this. If you need it, take notes. If you want to watch it, if you want to try it, okay, we're going to multiply it by the conjugate. Whatever you need, you guys make sure you're learning. Okay, whatever you did on the bottom, you need to do on the top. We're going to distribute this now. Not FOILing because it's just a simple, it's just one number. So it's negative 3 plus 15i all over 1 minus 25i squared. And you know that that I squared is going to cancel and it's going to change it to a plus, and it's going to end up being 26. And you're going to get negative 3 plus 15i. And none of these are divisible by 3, but 26 is not. So this is the final answer. Let's try this one. It looks a little more simple. What would you multiply I by? Okay, I'm going to actually write this here. Negative 6 plus 2i over I. This is a little easier, you guys. All you need to do is multiply that one by I. Okay, and then you need to put parentheses here. So we distribute the I, and you're going to get negative 6i plus 2i squared. Again, the I squared is going to change to a -1, which is going to change this to a -2 over I squared, which is going to change to a -1. Now, what does that do? That's so many minus signs to deal with. You have negative 6i minus 2 over -1. Well, this -1 is basically going to change the sign of all of these. We could factor out a -1 on the top if you want to be real delicate about it and get this. Okay, and then you could cancel your -1s, and then you would just get 6i plus 2. Or really 2 plus 6i. We usually put the real piece first, okay? All right, that's the final answer. Yes, whenever you're dividing by -1, it'll just change all the signs. All right, next one. That was the hardest thing. This is the last topic, and it says simplify I to the 55 as much as possible. Okay, so here's what I want you to imagine. We're going to actually go through this. I is I. I squared is -1, and you should write this down. What is I cubed? I cubed is I squared times I. And we have to talk about I squareds because that has a definition. I squared is -1, so this is negative I. Okay, what happens when we get I to the 4th? We get I squared times I squared, which is -1 times -1, which is +1. All right, what happens when we get to I to the 5th? Well, that's I to the 4th times I. So it's I to the 4th is 1. You can see it right here. Times I is equal to I. And look, we're starting to repeat again. I to the 6th, I to the 6th. You could break it into any pieces, you guys. I'm going to break it into I to the 4th times I squared. Okay, this is -1, and I to the 4th is 1. So -1 times 1 is -1, and we're starting the cycle over. Okay, now the reason why I went ahead, hello? Okay, where did it go? Okay, there it is. The reason why I went ahead and showed you this is because between I to the 1st and I to the 4th, you have 4 different answers. Okay, that's supposed to be negative I. Make sure that we have that, okay? You have 4 different answers. So when you're looking at these, you need to look at breaking them into I to the 4ths. Okay, how many I to the 4ths would go in here? Okay, because I to the 4th is just 1. So every time you get I to the 4th, it's just a 1. It's basically canceling it out. So, I mean, if you were really patient, you'd be like I to the 4th times I to the 4th times I to the 4th, right? Oh my goodness, this would be such a pain. So where are we at now? 16. We're only at 16, right? This could take a while. How many I to the 4ths fit in 55? Well, you would take 55 divided by 4, and you would get 4 goes into 5 once. 4 goes into 15. I don't know. Oh, I was thinking about something else. Sorry. Okay. It goes in there 14 times. So I would have to draw 14 of these I to the 4ths. Okay. And that's kind of silly. We don't want to do that. So 14, and then there would be 1 left over. Okay. Well, 14 times I to the 4th. Okay. 14 times I to the 4th times I. That's what I to the 55 is. Okay, I'm going to erase this. So basically we were left with 14 I to the 4ths, right? Okay, times I. Well, I to the 4th is 1. Actually, no. I don't want to put it like that. It just meant 14 I to the 4th, not the number 14. I didn't mean to put that. Don't want to put that. Go away. Forget I ever said that. Forget life. Okay, here we go. Okay, what it means is that I would have I to the 4th repeating 14 times, or the way we would put that in notation would be to the 14th times I, right? Well, I to the 4th is 1. 1 to the 14th is 1, and you would just get I. Basically, you don't even need to worry about this piece, you guys. I wanted to show you where it came from, but you just see how many I to the 4ths you can cancel out of this thing. So look at this one, I to the 61. You want to know how many 4ths go in there. So 61 divided by 4 is equal to 1. 4 goes into 6 one time. There's 2 left over. 4 goes into 21 5 times, and there's 1 left over. Okay, and then the remainder is 1. So this is very similar. Okay, you would have I to the 4th is going to take out all of them. It goes in there 15 times and there's only one I remaining, okay? Which means that this simplifies to simply I. Okay, if you need to, initially, you might need to do this and do it 15 times. I don't know if you do or not, okay? If you need to, do it, but this is the idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All of these just equal 1. So you can cancel them out, and then you got the little one left. And it's just I. That would equal 61. Do you guys see that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times 4 is 60, and then 61. Okay, it's kind of silly. All right, I to the 31. 31 divided by 4, okay, is going to be 4 goes into 31. It goes in there 7 times, which is 28, and then there's 3 left over, right? So what that means is you can cancel out the 7, and then you're left with I to the 3rd left over, because there's 3 i's left over. Okay, so that is equal to I squared times I. I squared is -1, negative I. This one just takes a little practice. I don't feel like it's very difficult, but I feel like it is one that a lot of times people mess up on. And if you want, okay, we could actually write like an actual rule, okay? Whoa, I didn't want to do that. Okay, here we go. Okay, we could actually write a rule. Like you take I, let's say I to the n. You could take n divided by 4, and then whatever is the remainder, that's what you use, okay? This is the number of i's left over. So in other words, if I have I to the 99, I would take 99 divided by 4, I would get 29, and there would be 1 I left over. These cancel out, and all I have to worry about, that's the answer, is I. Okay, if I were doing I to the 38, 38 divided by 4 is equal to 9, because 9 times 4 is 36, and the remainder is 2. So that means I squared is left over, which is -1. All right, and that's it for these notes.